Okay, hello everybody, hope everybody's doing good. I have a 3D presentation here specifically from one of our great researchers down in the great state of Texas. And this was dental teeth contained in the mandibular joint in the bone, and it was 3D rendered via the CT scan. So this example here shows kind of the lower teeth in the lower jaw, and that's one view. And then by doing some orthogonal, or I don't remember if they're perpendicular orthogonal planes, but you can start sectioning through the bone, and you can see, within the bone there's openings where maybe the nerve might pass and things like that. And again, I'm not a dental specialist, but this is pretty necessary. So again, making sections through here, they have different ways of looking inside the tooth in that way. Here's an example of an animation that shows the raw grayscale image with a calibration grid array in the backward, and I can play this animation forward here. You can see different perspectives of the sample, go through different passes of Z-planes. Okay. When you do apply an isosurface and get a measurement, we can also do sections through that volumetric isosurface render also. And in this case, the tooth is sitting kind of at an angle here, and we can now see this opening in the center, and this is where the nerve would pass through, and this was a particular definition that the particular researcher was interested in. So let's see, I think this just shows a visualization of kind of that occurring, and then we'll take some measurements here in a second. So kind of in this perspective, in that perspective there, where it ended up, now we're looking at it here. We can see this cross-section, and you can see this, we did quite a bit of enhancement here to the light direction, the orientation, and the reflectivity. And you can see that inside of this kind of this cavity here where the tooth, or where the tooth nerve is, provided a lot of detail about that inside cavity. And so that was accomplished again by changing some of the lighting conditions that we have within the Image Pro 3D module. And here's kind of how some of the measurements were made. Again, this is made with some of the manual measurement tools that are built within Image Pro that allow you to make, in addition to the 3D volumetric measurements, we can also make two-dimensional measurements within the 3D space. Okay, so here we took a couple of measurements across where the nerve width was. Okay, and again, data just like in the 2D. Shows up on our data table down below, and we can get all kinds of great quantitative information. And here I think what they were interested in is like the nerve width relative to the total tooth length. So they made basically 3 measurements here, and then they could either use something like data collector to do a calculation between nerve width versus tooth length, that kind of thing, and come up with a ratio there too if they wanted, or export it out to Excel and do some further calculations there. Here's another type of visualization of the same data set, and you can see a transparency effect that was applied to the one isosurface, which is the teeth themselves. That transparency then allows a visualization of the nerve inside the tooth, and you can see that occurring in several of these teeth in the front. Again, you can turn on or off any of the channels so that you can see exactly just the perspective that you're interested in looking at. And then here's a kind of a quick animation of turning on and off the different channels and some ortho and oblique planes that are being passed across the different tooth sections. So that's it for the PowerPoint side of it. What I'd like to do is get into Image Pro itself and take a quick look there too. So this is the data set that we were looking at a little bit ago, and I've brought it into the Image Pro. It opens it up immediately into the 3D view. Remember down here on the bottom, there's these two tools. We can go between the 2D visualization here, which is this icon. So now we have a player tool that you can play through the Z-Stack if you want, okay? And we can easily go back and forth between the 2D and the 3D modes, okay? Now, when you bring your image in, sometimes people say, well, it doesn't quite look like I would expect it to, and it's maybe a little bit lower resolution. Again, based on the performance of a particular computer that you're using, under the view, the 3D view tab here, on the far left over here, we can see these values for the X and Y, and this is showing the decimation that's occurring. So the X and the Y are being decimated a lot more than the Z-axis. And if we wanted to bring that resolution back, we can do that. And we can do that by going to reload over here, okay? And this is what you would want to do if you wanted to try to visualize this at full res. So what I would do is, you can see these values, the 9, and the 2. So if I turn this off and I'd say, let's just turn auto off and reset my values, now it's going to be 111. And what that means is, we'll give it a second to recalculate here. Then the image will come back and be rendered at full resolution, okay? Typically, the lower resolution is kind of nice to start with, especially as you're just trying to get started and maybe trying to set up your parameters and things like that, because that way it's easy to work with. But anyway, I'm going to bring, let me see, some of the other things we were going to look at was taking a look at the original render here and some of the controls that we have that with using that. These are the lookup table enhancements that can be applied to your data, and these have been enhanced a lot. You basically have full-scale spread on the minimum side and the maximum side, and then you have the opaque setting, which basically allows you to set kind of a threshold below which information will not be displayed. So those are actually really nice, the way that those have been engineered now. Once you're visualizing your sample like this, there's some optimization settings that you would probably want to use to optimize also. Under the composite window here, we set this to max, and then transparency also is kind of a nice feature that allows you to, let's say if you have multiple channels, to look between one channel and the next, okay? So just as a quick review, when you bring your images in, look at the volume rendering specifications over here, and if you'd like, you can maximize those for resolution if you want, or you can look at them, you know, somewhat decimated like this. Now, once you have your raw data here and you wanted to do some further quantification, then we can use these tools over here on the display bar over here, and we could add an ISO surface, let's say. So here's an ISO surface that can be applied here, and the colors, obviously there's different preferences, colors can be applied, and then the ranges for the segmentation can be applied, and then you can do a count, okay? Now, just like in 2D, I'm going to close this one. Let me add another fresh one here. So I'm going to use my grayscale value, and I'll go ahead and subsample that and do an execute count here. Just like in 2D, we can do our count, and on our, in this case, on our 3D tab, we now have our counts that are in range and counts of total, showing that if there's any filters being applied that are excluding things. We can actually define our segmentation a little bit better too. So let's say you wanted to define, say, the tooth like this. Again, the segmentation works very similar to like it does in 2D when you're doing like a bright or a histogram-based segmentation. Okay. Let's see here. Once you do your count, then you have your data. Let's see here, where's my data tables? You can bring your data tables up, look at histograms and things like that, just like we could do in 2D. let's see, what was the other? Oh, I guess an animation was the last thing I was going to try to show here. So if you're in here and you might want to do some animations here, you can use this keyframe animation tool. So you basically place the image in the orientation that you want, and then you just start hitting the plus sign here, and it will start adding frames. Okay, turn it slightly away, store that. Now you've stored a second. If you roll your mouse or grab the zoom tool over here and then hit the plus over here, it'll store that frame. So we're basically creating these keyframe animation, and I can play through those if you want. So you can hit the play button here, and it'll go ahead and play back through your animation. We can also, over here on this Output tab, create a movie, and then that movie again can be stored as, you know, the standard movie file formats, AVI, Windows Movie Video, or MP4s. Thank you very much.